The easiest way to define congruent figures is to say that congruent figures are exactly the same shape and size. However, in geometry, congruent figures have corresponding angles that are equal and corresponding sides that are also equal. When a line is considered to be perpendicular, it is at an angle of 90 degrees to a given line, segment, ray, or plane. A bisector is something that cuts something else in half. A perpendicular bisector is a line, segment, or ray that cuts a segment into two equal parts and meets it at a 90-degree angle. Can a line or an angle have a perpendicular bisector? I'm going to construct a segment that is congruent to segment AB. What I'm first going to do is I am going to take my ruler and I am going to make a nice long line with the ruler. You want the line to definitely look like it's longer than the segment that you're going to copy. And then what I'm going to do is I am going to put a point on the line, and that's going to be my end point. Now it's going to be a lot easier for you to just draw a point on your line where I had to use my circle tool. So here's my end point. Now what I'm going to do is I'm going to take my compass and I'm going to take the pointy end of it and I'm going to put it on point A, and then I'm going to open it up and I'm going to put the pencil end on point B. And I can make an arc like that, just to show that I did it. And then what I'm going to do is I'm going to bring my compass over here and I am going to make an arc across that segment or line that I drew before. And what I'm going to do is I'm going to give it another end point. I'm going to cheat. I'm actually going to clone this one because it'll be easier. And this segment is congruent to segment AB. I'm now going to construct a congruent segment using GeoGebra. So what I'm going to do is I'm just going to give myself two random points, bam, bam, and a segment between them. So right here is the segment that I am going to copy. So what I need to do now is I need to give myself a point down here, and I am going to make a ray coming from that point, and it's actually going off of my screen forever into infinity. Now, instead of having a regular compass, there is a compass tool in GeoGebra, and what that is you pick the radius. So this is going to be my radius and the second point is going to be my center. So I have now just drawn a circle with the radius that equals that original line segment. So now what I'm going to do is I'm going to take this circle and I am going to make its center my end point of my ray. And now what I go over here is I say intersect, and I am going to find the point of intersection between this circle and this line. There it is. Now if you don't believe it, what we can do is we can measure that distance is 5.89 units, and I can measure this distance and that is also 5.89 units. And that is how you construct a congruent segment using GeoGebra. Here I've drawn just a random angle, and what I'm going to do is I am going to construct an angle that is congruent to it. I'm going to start by giving myself an endpoint and array. Then I need my compass. And what I will do is I will open up my compass. What I'm doing is I am making just a random arc, okay? And I am going to bring this over to my ray, and I am going to make the same random arc, making it nice and big. Then what I will do is I will come over here and I put my pointy end where the arc meets one of the rays, and I put the pencil end where the arc meets the other ray. And what I'm going to do is I will make an arc there. And I will then move this over here. I actually need to flip it. And I make my arc, move my compass out of the way, and what I have here is a point of intersection. Here is my point of intersection. That will be where the second ray goes through. I have just constructed an angle congruent to a given angle. I'm using GeoGebra, and I am going to construct an angle congruent to a given angle. So to start, I'm just going to throw myself 3 points. Bam, bam, bam. 3 random points. And I will make an angle. So that's going to be my given angle. And now I need to work with a ray. All of my constructions, in case you haven't noticed, have started with a straight line. That's where you start. Now, when we used a compass and a straight edge, we used our compass here, we use our compass tool. I think it'll be easier for me to actually put a point right there. I don't want my circle to be huge. I don't need to be working with huge circles. And if you recall, this will define my circle, the radius of my circle. So now I'm going to find the point of intersection of these two, and I need that there. And I'm going to do the same exact thing again. I'm going to make a circle with this radius, and I'm going to bring it over here, and I need to find the point of intersection of these two because that's important. Now what I do is I go back to my compass tool and I use as my radius the distance between the two arcs. I'm going to take that and bring it right over here, and I now have my point of intersection, and there it is, and that is where my ray will travel through. And I can take the handy dandy measurement tool and say, okay, measure this angle. Well, the outer angle is 312.99 degrees, and so is that one. So you can see I have just constructed an angle that is congruent to a given angle using GeoGebra. This is the construction of a perpendicular bisector using a compass and straight edge. I don't really need the straight edge for this one, I just need a compass. What I did was I gave myself a segment. I need my compass, and what I need to do is I need to open it more than halfway. That is very important, that you open it more than halfway. And what I'm going to do is make an arc from one end point, and then I am going to flip it and do the same thing from the other end point. Move it out of my way, and what I have is 2 points of intersection right here and right here, and my perpendicular bisector passes through those 2 points. That is a very thick line, but it's okay. And I have just bisected that, and it met it at a 90-degree angle. You're going to love this one. What we're going to do is we're going to construct a perpendicular bisector of a segment using GeoGebra. I first need a segment. I'm giving myself a very random segment. It's actually oblique. We usually start with horizontal lines, but there it is. There is actually a command in GeoGebra that says, construct the perpendicular bisector, please. So we're going to click on that. We're going to click on this segment, and there's the perpendicular bisector. But what I'm going to do is I'm going to show you that what we did with the compass works. I'm going to pick a point on the line and then use my compass tool and have my radius be more than halfway. And that is one circle. And I am going to do it again, but the circle will be over here, and you can see that my 2 points of intersection right here and right here are where the perpendicular bisector passes through. Pretty neat. This is how you bisect an angle using a compass and a straight edge. I start out with a given angle. I take my compass and I make an arc, again just random, across my angle. Now what's important, as usual, are the 2 points of intersection. I'm going to put my point at one of them, and I'm going to make an arc in here. And then what I'm going to do is I am going to put my point at the other one, and I am going to make an arc there. And here I have a point of intersection. And that is where the angle bisector passes through. We're going to construct an angle bisector using GeoGebra. As usual, I'm going to start by just giving myself a random angle, like so. Right here, there's my angle. I'm going to have tons of lines on this canvas when I'm done, so I am not making them rays, I'm making them segments. Now, there is an actual command for GeoGebra to give you an angle bisector. I'm not going to do it that way. I'm going to do it with the compass. What I first need to do is I need to put a point on one of these lines to define a radius for myself. And here is my radius. I need to find the point of intersection like so. Now what I will do is I will make an arc with the same radius from each of these points, and where they intersect is where my angle bisector passes through. And what we can do is we can measure this angle right here. 38.49, and that's also 38.49. And if you'd like to see, I can construct the angle bisector, but it is simply going to go over this line. You're not going to see it actually show up because it's going to be concurrent with the other line. But you can see how if this endpoint were down here further, it would move. And there's my angle bisector.